Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today's going to be a topic that you've, again, probably talked about in middle school, but it is something that we're going to use fairly frequently in this class as well, so we got to go back over it again. And that is the Pythagorean theorem and the converse of the Pythagorean theorem. So to get us started, we're just going to practice solving some quadratic equations. We have numbers 1 and 2 there. Pause the video, take a minute or two to solve those, and then rejoin us. All right, so for the first one, we need to isolate the x squared. We can also simplify the 6 squared. So I get 36 plus x squared equals 100. If I subtract 36 from both sides, I get x squared is equal to 64. And if I take the square root of both sides, I get x is equal to plus or minus 8. Remember, there's a positive and negative root when we take the square root of a or of a positive number, rather. So x is equal to plus or minus 8. Number 2, I'm going to have x squared is equal to 20 when I subtract 45 from both sides. If I take the square root of both sides, this doesn't come out as nice, right? I'm going to get x is equal to plus or minus the square root of 20, which I can break down into plus or minus the square root of 4 times the square root of 5, which is equal to plus or minus 2 times the square root of 5. This is the exact answer. Okay, and if you wrote down a decimal, that would be an approximation, right? Because you're having to round. The square root of 5 is irrational, so you have to cut it off or round it someplace. So if they're asking for the exact answer, this is what you want to do. You want to break down the square root as much as you can by finding those perfect square factors. Real quick, let's talk about one other thing with this. The square root of 20 can be broken down into the square root of 10 times the square root of 2. The problem is both of those are also irrational numbers. So when you're breaking down a square root, you want to see, can I break it down into something that's a perfect square, right? 4 is a perfect square. So when I take the square root, I'm going to get a whole number, right? So those are the kind of factors you're looking for, perfect square factors. All right, let's get started. Let's do some vocab. The Pythagorean theorem. In a right triangle, so the Pythagorean theorem works with right triangles. You'll see some applications we have for it with other triangles, but for right now we're going to keep it to right triangles. The square of the hypotenuse is equal to the sum of the squares of the other two legs. Should be a period right there. The square of the hypotenuse is equal to the sum of the squares of the other two legs. Now, what do hypotenuse and legs mean? Well, they're both sides of the triangle, but we have to know which ones they are to be able to set up our equation correctly. So the hypotenuse is the side across from the right angle. We'll say across from. You could also say opposite. Now that I think about it, that's probably why I just had one blank there. You could say across from the right angle or opposite the right angle. It is also the longest side. Now here's the problem. Sometimes it may not be clear exactly what side is the longest side. There may be two sides that are really close. So if you can identify the right angle, right angle here, so the side across from the right angle, C, is going to be our hypotenuse. This works every single time. The hypotenuse is always opposite or across from the right angle. So in this yellowish triangle, our hypotenuse is C, and our legs are A and B. And here's the equation. A squared plus B squared equals C squared. It doesn't matter if you do B squared plus A squared, because as long as you have both of the legs on the same side and the hypotenuse by itself on the other. So again, a formula it's actually like the one formula that students come into geometry almost every student having memorized. But again, you want to make sure you understand all the pieces of it so you can apply it correctly. All right, let's do some practice. I would encourage you to pause the video, and the ones we are going to work through in the video are going to be 1 and 3. We'll actually do 1, 3, and 5. So I'd pause the video, go ahead, try to complete numbers 1, 3, and 5, and then come back and see how your work matches up. All right, so we're working through number 1. First thing I would do is find the hypotenuse and label it, whether it's one of the sides that's given or whether it's one of the sides that doesn't have a length like that does here. Make sure you know what side the hypotenuse is so you can put it in the right spot in your equation. We'll just call this x. So I'm going to have 1 squared plus 4 squared is equal to x squared. I'm going to get 1 plus 16 is equal to x squared. I'm going to get 17 is equal to x squared. And you'll notice that here it says provide an exact answer and an approximate answer rounded to the 10th place. So I need 2 answers here. I need the exact answer. Well, that's going to be the square root of 17 is equal to x. That is our exact. And if I take the square root of 17, well, we're going to round to the 10th place, and that's going to give me approximately 4.1. So we can also say that x is approximately equal to 4.1. We should have units here as well, inches. Let me put the inches over here. Square root of 17 inches. So again, they're asking for 2 answers, one the exact, one the approximate. The one that's approximate will have these squiggly equals signs, right? They're not straight. They're curved or squiggly or whatever you'd like to want to describe them by. They're called approximately equals. So when they're a little curved, that means approximately equals. Now you may wonder, Mr. Fawcett, we had 2 answers when we took the square root up in our do now. Why are you only giving the positive answer here? Well, if we're talking about a figure and lengths, you're never going to have a negative side length, right? So your side length has to be positive. So in this case, we don't have to worry about the negative root. And this comes into play when we're doing word problems or figure problems. Even though you may get 2 answers, sometimes you may not need the negative one, right? If your answer has to be positive. So you can always keep that in mind. All right, moving on. Number 3. What is the length of the unknown side of the right triangle below? We again need to provide the exact answer and an approximate answer rounded to the 10th place. I'm going to label my hypotenuse. Remember, that's across from the right angle. So this time it is given. It is 8 inches. I'm going to label my unknown side as x. So I get x squared plus 2 squared is equal to 8 squared. Notice that this time our x is on the other side of the equation. It's one of the legs. So again, diagram could be given in many different ways. Sometimes you're finding the hypotenuse length. Sometimes you're finding one of the legs length. So we're going to have x squared plus 4 is equal to 64. And then I'm going to have x squared is equal to 60. Could take the square root of both sides. And we're only going to take the positive root. So I get x is equal to the square root of 60. You got to think, can I break this down at all? We couldn't break 17 down up above because it's prime. But there is a perfect square factor of 60, right? That's 4. So square root of 4 times the square root of 15, that gives me 2 times the square root of 15 inches. That would be our exact answer. Notice I can't break down 15 anymore. Even though it's not prime, it doesn't have any perfect square factors. All right, let's give an approximate answer. If we punch the square root of 60 into our calculator, we get approximately 7.7. So we can also say x is approximately 7.7 inches. Usually they're just going to ask you on a test or exam or standardized test. They'll just be asking you for one or the other. They won't make you find both generally, but it's good to know the difference between the approximate answer and the exact answer. All right, I think the last one we're doing for this section is number 5. So let's head down there. This time it does not say if we have to provide the exact or the approximate. So it's probably our choice, or maybe it's just going to come out as a nice, neat whole, or well, it would have to be a natural number because it's never going to have a length of 0. So let's label our hypotenuse. That's the one across from the right angle again. I'm going to call that x. And this time I get 3 squared plus the square root of 27 squared. So that looks a little different than what we've had before, is equal to x squared. 3 squared is 9. Now the square root of 27 squared, well, the square root and a square, those undo each other. Those are inverse operations. So I'm just going to be left with 27 is equal to x squared. And you can see this one's going to come out nicely. So I get 36 is equal to x squared. If I take the square root of both sides, I'm going to get x is equal to 6. And we are in feet. So let me rewrite that. Well, I can just rewrite it over there. It's okay. So x is equal to 6 feet. So there was no approximate answer here. There was just an exact answer. Okay, the other ones you can work through on your own. We'll probably go through some of those in class. Basically, you're just trying to find the different sides. There are a couple of different ones in here. If you take a look at number 6, it only gives you one side length, but it tells you it's an isosceles triangle. So you may have to use some prior knowledge from middle school geometry and try to understand why we're still able to figure out the missing sides, even though they only give us one side. But we do have one more thing to do today, and it is the converse of the Pythagorean theorem. So remember with a converse, that is when we switch the hypothesis and the conclusion. So if we go back up here to the Pythagorean theorem, in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So the statement here, if we think about this as a conditional statement, this would say, if a triangle is a right triangle, then a squared plus b squared equals c squared. And you'd have to say what a squared, or you'd have to say what a, b, and c are, but I'm just condensing it. So if we have a right triangle, then a squared plus b squared equals c squared is true. The converse down here would be, well, if a squared plus b squared equals c squared is true, then the triangle is a right triangle. So we've just switched the hypothesis and the conclusion. So now we're going to be given 3 side lengths, and we have to determine, well, is this a right triangle or is it a different triangle, right? And you're not going to have to say whether it's, an acute or obtuse triangle. We haven't really talked about those yet. You just have to say whether it's right or not. Okay, let's just do number 9. It says, this is a triangle with leg lengths of 3 miles, 8 miles, 3 miles and 8 miles, and a hypotenuse of length, the square root of 73 miles, a right triangle. Show your work and answer in a complete sentence. Let me fix this real quick. Okay. So let's set this up. Make sure we put our numbers in the correct spot. We are said that the hypotenuse is equal to the square root of 73. So I'm going to have 3 squared plus 8 squared is equal to the square root of 73 squared. And we need to see if this equation is true. So I get 9 plus 64 equals, well, remember, this square and the square root undo each other, so we're left with 73. And I get 73 is equal to 73. So yes, this is a right triangle. Let's fix that a little bit. Yes, this is a right triangle because a squared plus b squared equals c squared where A and B were the legs and C the hypotenuse. That would be a complete justification. Again, you don't want to just say because a squared plus b squared equals c squared, because people need to know what those letters represent, right? I could have said x, y, and z and said, well, x and y were the legs and z was the hypotenuse. The A, B, and C aren't important. It's understanding what they represent that's important. So that's why it's always important to give that little extra and explain what those different letters or variables represent, rather than assuming the reader knows what you're talking about. All right, let's do one more. Let's do a word problem. See which one we want to do. And we'll just do the first one. So it says you are trying to take down your Christmas lights from your house. A 15-foot ladder rests against the side of your house. The foot of the ladder is 5 feet away from the house. Find how far up the house the ladder reaches. Round your answer to the nearest tenth of a foot. So again, I like to draw a diagram that helps me visualize what's going on. So I'm going to say, here's my house. We'll make this a very general house. You really don't even have to give this much detail. A simple line would suffice. And I have a 15-foot ladder. So the length of my ladder is 15 feet, which means this is how I'm going to label that 15. And it is 5 feet away from the house, the foot of the ladder. So this distance right here, 5 feet. And we need to figure out how far up does it reach. So what is this distance right here? That's what we'll call x. Well, we need to identify where the right angle is. It's going to be right here. So our hypotenuse is 15. So I'm going to have x squared plus 5 squared is equal to 15 squared. And I can go ahead and simplify, or solve rather. Simplify and solve. 15 squared is 225. So I get x squared is equal to 200. It does not say to find an exact answer here, so I just have to take the square root of 200 and round to the nearest tenth of a foot. So x is approximately equal to 14.1 feet. So it reaches 14.1 feet up the house, up the side of the wall. You can write your square roots in there as well. One thing to kind of help you check your work, right? If you had gotten an answer that's larger than 15, well, you would know that wouldn't make sense, right? And you'd have to go back and rework your equation. Because if you set this ladder straight up, right, the highest it could go on the house is 15 feet, right? If there's no way for it to go any higher because the ladder only reaches a length of 15 feet. So let's say you did 5 squared plus 15 squared equals x squared, and you got something that was like 16 or 17 feet up the house. That should be a little signal that says, hey, wait a second, based on what the problem says or how I set up my diagram, that can't be an actual number. So you could go back and rework your equation. Again, think about what your hypotenuse was, what your legs were, etc. I know in this example, it doesn't, it's a fairly straightforward one. So you may be saying, like, look, I know my answer's right. I set it up. It was an easy Pythagorean theorem equation. When the diagrams get more complicated, when the questions become a little bit more conceptually difficult, it is important to think about whether your answer makes sense. And that'll be true in all of your math classes, right? All the way up until you make it to calculus, if that's a class you take in high school. So, all right, this will do it for this video. We kept it just under 20 minutes. Enjoy the rest of your day, and I look forward to seeing you next time.